Yes, hello everyone. I can see that a lot of people are joining in. So we will soon start with our session, but I will maybe first give a short introduction myself, and then I will introduce the two other speakers here today. So my name is Annelies van Dijk, and I am the project manager of the SciComm Academy at SciMingo. And SciMingo is a Flemish nonprofit organization based here in Brussels. And we want to help people take their first steps into science communication. And for this, we have various projects, and specifically with our SciComm Academy, we want to help researchers share their work with a broader audience. And we do this on one hand by organizing free monthly online lunch talks like the one of today, that cover a wide range of topics related to science communication or research. And our next lunch talk will be on the 13th of June. And this will cover the topic of how to stand out with your scientific poster. And for this, we invited Toon Verlinde from The Floor is Yours with us. And you can find the registration link for this talk in the follow-up mail or also on our website by scanning this QR code. On the other hand, we also organize in-person training courses here in Brussels. And we then want to help you reach out on various platforms or using different tools. For example, we help you to turn your research into a captivating 3-minute video pitch or into a blog post, but we also help you optimize your social media identity and which platforms to use when. So you can also find all of these courses on our website, and I'm excited to announce that we just launched our program for this fall season, where you can find all of the new courses. And with that being said, we have 2 new training courses this season. One will be on poster design as well, a hands-on training, and the other one will be on how to use ChatGPT for science communication. And this, of course, is related to our talk of today, for which I'm joined today by Andres and Lisa. Today, Andres will tell us all about generative AI. What is this? How does it work? But also, what are the opportunities and the risks for using this technique in your research or in your science communication? And before I give the floor to Andres, I'm also very excited to announce that we are co-hosting this talk with VAIA, and VAIA is the Flemish AI Academy. And to make you know what VAIA exactly is, I will give the floor first to Lisa, who will give a detailed explanation of this initiative. And I just want to end by, as always, encouraging you to ask your questions for Andres in the Q&A window or in the chat. And please do this throughout the talk so we can really target your specific needs and questions with this talk. So with that being said, Lisa, I will give the floor to you.
Yes, thank you. I will share my screen and open my slide here. Okay. Yes, I'm afraid I will minimize the 2 of you, Annelies and Andres. Can you see my slide?
Yes, perfectly.
Okay, thank you. So hi, everyone. I cannot see you, but I hear from Annelies that a lot of people are here. So I'm Lisa, and I'm representing VAIA, the Flanders AI Academy here. We are co-hosting this event with SciComm, and we're very happy to co-host and to introduce Andres, who is a great speaker and also a former colleague of us at VAIA. So what is VAIA? Very briefly, who are we? We are a non-commercial partner, so this is not a sales pitch. And we are a collab between all of the universities and colleges in Flanders. And our mission is to channel the AI expertise that is in higher education in Flanders, to channel that towards Flemish professionals like yourselves. So what do we do? Our core business is lifelong learning on AI for professionals, for researchers, for teachers, for science communicators, whatever your level of expertise is, from beginner to expert. And on our website, we aim to actually collect all of the AI trainings that are happening in Flemish higher education, but that are open to a broad audience. So on our website, we have more than 200 training courses. Some of them are co-organized by us. Oops. And some of them, oh, you can no longer see my slide, right? And some of them are just promoted by us. So I'll briefly show you what our website looks like, as this can be useful to you. So it's vaia.be. Voila, you can have it. This is the Dutch version, but you can easily switch to English. If you go to vaia.be, we have a course calendar. You have it here. So the course calendar, this is an exhaustive overview. So it's pages and pages long of everything that we promote or organize. But if this is a bit overwhelming for you, just filter here, say that you want to focus, for instance, on a one-day workshop in humanities, that it has to be English, that you prefer it to be in Ghent, and whatever. You can filter on a lot of things and find something that you like. You can also filter on your level of expertise, whether you're a newbie in AI or an expert, you can filter on that. So make sure to go to our website, to vaia.be. You can subscribe to our newsletter, then you don't have to go to our website or our calendar all the time. Then you can just get updates in your mailbox. And you can befriend us or connect with us on LinkedIn to stay in touch as well. So that's just what I wanted to say about VAIA. So let me know if you have any questions, and I hope you can find something to your liking on our website. Thank you.
Okay, Andres, then the floor is all yours, and we're very excited for your talk.
Okay, thank you. I believe you see my screen. Okay, so let's start. Hi, everyone. I'm Andres Algaba, postdoctoral researcher at the Vrije Universiteit Brussel. And today we'll be talking about the potential of generative AI in research and science communication. So the most difficult job today was to design a talk for only 1 hour, because about generative AI and large language models, we could talk for hours and hours. We actually do it at the VUB. We have some generative AI sessions in which we discuss what are large language models, how do they work, how do they learn, what are hallucinations. And so today I can only limit this talk to 1 hour. And so I will touch upon many of these things, not like completely in depth, but I will actually talk about what are large language models, how do we use them, how do they learn, etc., etc. Because I also believe that it's very important for users or developers both to realize actually how these models generate text or images. Because I think from first principles, when we see actually how these texts are generated, that we actually can deduce many appropriate uses of these models. If we realize how they learn, which data they use to learn, processes they use to learn, the processes they use to generate new stuff, we actually also realize better what the potential pitfalls are in using these systems, but also what their potential use cases are. So also because it's kind of like a first talk of a series, as I understand, in SciMingo, many more practical oriented talks will also appear after this. So I think a good start is to start from first principles. So today we will start with 3 questions, and it's a what, a why, and a how. I know I should always start with a why, but what are large language models is the first question we'll deal with today. Then we will see actually why large language models are useful, like why are we even talking about them? And then we'll go more into depth, like how we should use them. I will not tell you like how you should use this, because again, ethically and morally, there are many things to talk about also from a ecological point of view and so on. So again, this is only 1 hour introduction. I will touch upon lots of things, but not truly in depth. Maybe also a choice I made today is I will not really specifically talk about any particular system or tool, because there's many out there, consensus, etc., etc. And I'm glad I didn't, because today actually 2 new models are out, and actually my talk would already be updated. Claude is now available in Europe. And yesterday evening, our local time, OpenAI actually introduced GPT 4.0, which we'll shortly talk about. So let's start with the first question. What are large language models? And I think the best way to explain large language models is to actually start from the abbreviation GPT. Nowadays, we know GPT as a commercial product by OpenAI, but actually 7 years ago, the term GPT came to life as the Generative Pre-trained Transformer. And this was a name for a new type of architecture where, well, we have 3 words: generative, pre-trained, and transformer. And so let's dive into each of these 3 terms. And let's start with generative. What actually does it mean for a model to be generative? Well, generative in this case with text means that there is a model which makes a prediction. That is what models often do. And it actually predicts the next token or word based on a given context or prompt. So in this example, we see that cat sat on a is the context or the prompt which is given to a model. The model performs a bunch of computations, and it then predicts the most likely next word with some probability or next token. So this is actually what the generative part is. Normally we think, or often we think about AI models or machine learning models as being able, for example, to classify a dog or a cat picture, like is there a dog, is there a cat in this picture? Now the prediction is not a classification, but the prediction of the next token. And we are already very familiar with this. Think about, for example, autocomplete in chat. Now, I'm talking about tokens. Why aren't I talking about words? Well, because, and this is something very important to always keep in mind when you discover kind of like buggy behavior in large language models, they don't operate on words like we do, they operate on so-called tokens. And tokens are sometimes words, sometimes subwords. And here with the color indications, you see that token is a word, token is a token, ization is a token, is a token, at is a token, and so on and so on and so on. And you see that many words can actually be represented by a single token, but some words are actually multiple tokens. What you also see, and the reason why large language models tend to work better in particular languages, is that the tokenizers recognize more English words than Dutch words. If you look at de het is ook een reden waarom andere talen soms minder goed lijken te werken, you see that it consists of many more tokens than the English sentence. Tokenization is at the heart of much weirdness of LLMs. So what we actually see here is that, well, texts are being tokenized, but tokenizers are trained on data, and there's more English data than Dutch data on the internet. So tokenizers will have a much easier time to recognize English words than they do for Dutch words. And this will have some consequences toward the capabilities of these models in other languages. Now, tokens are not only words. Actually, everything which you can express as a token, everything which you can express as a sequence, sorry, I was looking at the chat, everything which you can express as a sequence can be expressed as a token. So for example, also the code, which you see here at the bottom of your screen for I in range 1 to 101, is also just a bunch of tokens. So these models actually can read anything which is a sequence, which is also code, mathematical formulas, or even images. Now, so the generative part is next token prediction. You give a bunch of tokens to a model and it predicts with some probability the next token. Now, the second term in GPT is pre-trained. Pre-trained, funnily enough, it seems like you do this before training, but actually it denotes the bulk of training in a large language model. What we actually do there is just next token prediction. We do it on a huge amount of data. Think about a large chunk of the internet. The training often takes multiple days on like thousands of GPUs. As a consequence, it's also very computationally, but also money-wise expensive operation. So you see that many corporations which train large language models actually don't share them, don't open source them, partially the reason here is that they have a competitive advantage, but also because it costs a lot of money to train these models. A notable exception there is Meta with the Llama series of models. And after training, and training again is just predicting the next token, and each time you predict, you actually optimize, you try to optimize the model, and eventually you just have a file with a bunch of computations, and this is your model after training. Now, to get a little bit more into this, again, let's consider the context. Roof was un, then we have a model, and then we have a prediction. And what we actually see here is that the prediction, like I said, are a bunch of tokens with some probability. We see that, for example, the next most likely token, according to the model at this point, is American with 59%. Inventor is also there with 22%, and so on and so on and so on. So now, in reality, because we have access to the data, we know what the next token should be. So what we can then do is we compute a loss, and the loss is just the difference between the ground truth, like which token was actually next, and the predictions made by the model. So for example, if the next token was inventor, then we only are, you could say, 22% right. So 22 out of 100 cases, we would have predicted the most likely next token. All the others we didn't. So what we'll now do based on this loss is adjust the model, adjust the parameter, so that next time the model makes a prediction, it is actually closer to the ground truth. And we do this for days and days and days on a chunk of the internet, and eventually the model gets better and better at predicting which token is most likely to be next. Now, again, to give you an idea here, GPTs are pre-trained on internet data, like I said, and to already give you a glimpse on why this is a very difficult task and why the model is very capable at the end is because predicting the next token actually means predicting a lot of facts, also a lot of grammatical stuff, and so on and so on and so on. For example, when we are talking about Ruth Handler, and in the previous slide, the sentence was about her, Ruth was un. Now, Ruth was many things. She was indeed American, but she was also an inventor. So you see here why the model assesses some probability to the next token. Actually, often many tokens are possible to be the next token, and it just gradually becomes better at predicting which ones are more likely, but the model will never be 100% sure on which token is the most likely to be next. Also, when I talked about the tokenizer, I said that it's better in tokenizing English text compared to Dutch. Well, you see why. This is an example for the Llama 2 family. We see that 90% of the training data was in English. So therefore, many models are actually much more capable in English compared to other languages. The 8% unknown is not like we don't know what language it is. It's mostly code which has been written. So the model is actually predominantly trained on English and code. And so not much data out there on other languages. Okay, so we had the generative part, we had the pre-trained part, now the transformer. The transformer, we're not going really to delve into this, but I just want to kind of put the emphasis on that that predictions are always conditional on the context and the prompt. What do I mean with that? Next token prediction means literally that you predict the next token based on the entire context and prompt that you have given. But the model decides actually which words in the context are most important to make that prediction. And this can actually give you some intuition on why biases and so on start to exist in these models. For example, with the sentence, the doctor asked the nurse a question, she, the model predicts set, and the model predicts set based on she and nurse. So the model actually believes that when I refer to she, that I'm actually referring to the nurse. Because when I put the same sentence there, the doctor asked the nurse a question, and I put he, the model for the next token prediction puts a lot of emphasis on he and doctor. So somewhere in the training data, the model has learned to associate he more with doctor and she with nurse. the model is not designed to be biased, but the data it has been trained on, namely the internet data, just contains a lot more associations between she and nurse and he and doctor. And so these are very little things, and this is like a famous example which we all understand, but you have to realize that there's many more subtle biases and also factually wrong information on the internet, but all of this creeps into the parameters of the model. So this is something which we will also take away, like when we deal with how should we use this model. Well, I think it's important that you realize predictions are made based on the context, but the associations the model has learned are all based on internet data. So always keep that in mind when using these models. Now, once the model has been trained, so we have a GPT, how are we going to use it? Because, well, you're talking about next token prediction, and actually, when I use GPT, it generates entire sentences or text. How does that actually work? Well, it just predicts the next token, but it keeps doing it. So if I feed the sentence "he is" to a large language model, it will predict, for example, the word "a." And the GPT is done. It has done what it should do. It has predicted the next token. Now, what I do then, just autoregressively or recursively, I give now the predicted output as an input to the model, and I feed it the sentence "he is a." And now it just makes a new prediction for the next token. And that's how the model eventually creates sentences and creates entire text. So the amazing thing is that this works. By just predicting the next token, you can eventually get coherent pieces of text. The early GPTs could not do this. The newer GPTs from like 2 or 3 years ago starting are actually able to do this. And this is kind of like the amazing thing. Now, again, I want to emphasize that because you often get the remark by people, yeah, okay, so it predicts the most likely next token, but each time I ask the same question to GPT, it gives me a different reply. Well, this is because it indeed predicts probabilities over tokens. So when I feed the text, the model predicts each token with a certain and then blank. So I want the model to make a prediction. It will actually generate a probability for tokens. It will say the word probability has 67% chance of appearing next, confidence has 5% chance of appearing next, likelihood 4%, and so on, and so on, and so on. Now, what will happen in practice, I will actually draw a word from this probability distribution. So when I feed the text, the model predicts each token with a certain. If I do this 100 times, 67 out of these 100 times, I will get the word probability. 5 out of 100, I will get confidence, and so on, and so on, and so on. And you see, if you do this iteratively, that, well, chances are quite large that you will never end up with the same response to the same query or prompt. So it is just trained on internet data to predict the next token based on the context. But quite unsurprisingly, we've all been on the internet and it's not the most helpful place. So these base models are often very hard to use. And so these are GPT models. How do we actually get to ChatGPT models? Well, we have some additional training steps. So the pre-training is done. We have a GPT, but now we want to make it a ChatGPT. And we do this in 2 steps. And the first one is called, or was called, Instruct GPT. This is kind of like fine-tuning a base model into an assistant. Now, what happens here? Well, if I give a prompt, on the left-hand side, you see, for example, explain the moon landing to a 6-year-old in a few sentences. Now, if I give this prompt to GPT-3, which is just a base model, it will actually perform the autocomplete, right? It will predict the most likely next token, and the most likely next token here is explain the theory of gravity to a 6-year-old, explain the theory of relativity to a 6-year-old in a few sentences, blah, 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 blah. This is not helpful at all, or not what I asked at all. So what we will actually now train the model to do is to actually respond to our queries. So we will give the model prompt, and we as humans will write a completion for the model. So the prompt explain the moon landing to a 6-year-old in a few sentences, we actually write down the desired response, which is something along the lines of a giant rocket ship blasted off from Earth, carrying astronauts to the moon, blah, 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 blah. And so what we will now do is we will actually continue training the model, but on this very curated data set of human replies to prompts. So we'll actually kind of force the model not to predict the next token on the internet that it has done in the pre-training phase, but to actually fine-tuning it to respond to our request as an assistant should. So after training, so again, if we have write a short poem about a wise frog, you see that GPT still does what it does. It predicts the most likely next token, but the instruct GPT, the GPT which has been fine-tuned, actually starts to produce something which we would like, which is a short poem about a wise frog. The frog is a symbol of wisdom, etc., etc. So this is the first step. We actually have a curated data set, which kind of like forces the model to not only predict the next token on the internet, but to actually predict the next token as if it were an assistant which replies to our queries, to our prompts. Now, note here already that the behavior of the model actually depends a lot on what kind of information we feed at this stage, right? So we move away from predicting next token on the internet toward steering the model to a certain kind of like behavior, I would say. Now, in the second step, we improve this even a little bit by using something called reinforcement learning through human feedback, RLHF. Now, why do we need the second step? Because the first step, it kind of learns the model a template on how it should reply to prompts, but it's very data intensive because humans have to write this, have to curate this data set and so on and so on. And we will never be able to capture all the desired behavior within this data set. So now we will do something less data intensive, which is, well, we have seen that GPT models generate or potentially generate multiple answers to the same query, right? We give a prompt to a model, and because of the stochastic behavior of these models, they may actually generate many different replies, right? Now, what we can do then is just rank these replies from most helpful to least helpful. So say that we give a query to a model, for example, give me some feedback on this text that I wrote. And maybe the first reply is no. Well, that's not very helpful. So we will rank this towards the end. Maybe a second reply is, this text sucks and you're really stupid. This is something which you also don't want to see. Maybe a third one is, well, you made a lot of mistakes. Still not very helpful. And then, but at least this is a little bit better than saying that our text sucks and so on. And so then eventually there will also hopefully be some good answers where it actually gives some useful feedback. And these actually get top rank. Now we will use this ranking then to train the model through reinforcement learning to actually only produce desired replies. Now, I cannot stress this enough, and this will come back through the presentation. This is a very dangerous step. It makes the model useful because it will actually, well, give replies which are useful or perceived to be useful by us, but humans are flawed. We will actually rank, make a ranking based on our subjective feeling whether something was helpful. And this will generate some different kinds of behavior in the model because, for example, humans like to be right. So everything every time the model says you are right, we will actually like that answer more than the model saying we are wrong. And we have to not lose focus here on the fact that we are no longer predicting the next word. At this time, we're actually training the model to become more helpful, but more helpful is not always more truthful. So keep that in mind. This will come back. Okay, and then a last step of the training So this is also something when I'm talking about like tools offered to you by companies, because you have like these famous base models, right? Or chat models. You have OpenAI GPT, ChatGPT. You have Gemini. You have Claude now also available in Europe. You have Llama, open source. And all of these models are so-called general purpose. They're not really specialized. Sometimes companies actually will maybe sell you a license to a so-called specialized model. One of the things that they may have done is something called fine-tuning. What is fine-tuning? Well, after this pre-training phase, after the phase where you have turned the model into a chat model through either instruction training or RLHF, you may actually feed some additional very specific data to the model. For example, you want the model to become a specialist in medical data. Well, you may then feed a lot of medical documentation to the model in an additional training phase. And this is to kind of specialize the model towards a certain task. So these are the specialized models. And again, when a company says that they have a special model for a task, often one of two things, and the other thing we'll talk about later, but one of two things that they may have done is continue training another model to specialize it towards some task. Okay. So, and again, feel free to ask questions at any time because I realize that I'm kind of going fast. But again, you can also review this or always reach out for questions, but only an hour feels like very short to talk about large language models. But we have arrived to the second question, which is why are large language models useful? Because, and this is kind of like we're very rapidly accustomed to these things as human beings, but I'm sometimes still amazed that this actually works. It's predicting the next token. Why should that be useful to me at all, right? Well, to give you some idea why these models can actually be useful to us, let's think about what it means to predict the next token. Predicting the next token, according to me, is extreme multitask learning. What do I mean with that? To be able to predict the next token is to be able to solve, at least partially, many tasks. And I've given you some examples here. For example, when I give a model the prompt, in my free time, I like to, well, it can give several replies. One can be run, another can be banana. And to know which one it should give as a reply, the model should have some feeling with grammar, right? It has to know that a verb has to be next. Another one is I went to the zoo to see lions and, well, both zebras and spoon, or spoons maybe, could grammatically work here. But since, well, lions are animals, and since the zoo often has animals on display and not spoons, zebras seems like the most likely next token. But again, it has to have some lexical knowledge about lexical semantics here. Another one is sentiment analysis, for example. I really like the movie. The movie was, well, to predict the next token, I have to somewhat know how liked a movie fits with whether a movie was good or bad, right? So you see, implicitly, predicting the next token has lots and lots of tasks embedded in it. Okay, also when you see a math question, 3 + 8 + 4 equals, well, if this was not in my training data, I kind of have to be able to compute a little bit to be able to see what the next token should be. Also translation and so on and so on and so on. But so why are large language models useful? Because while trying to predict the next token, it seems that they pick up a lot of tasks. And so sometimes people say that large language models are good to automate the boring stuff, but because of their capabilities getting better and better by predicting the next token, we also, I would advocate, could use them as a general purpose tool. Also, that is why I always don't feel in a good position to recommend people how to use these models. Well, be as creative as you want. Like, be ethical in your use and be like very cautious in your use, but also be creative. For example, you can use it to write code. You can use it to solve mathematical or help you to solve mathematical exercises and to explain to you why this is the case. It's more than just an autocomplete, right? It can help you to explain things. And again, we have to be careful with hallucinations, which I will talk about shortly. But there are many tasks embedded within large language models potentially, which could actually help you to explain stuff, to help you become a little bit more creative. And it's not always obvious what a large language model can do unless you ask it. So really experiment with it is what I would advocate for. Now, something which we also then often run into is a fight on Twitter or X nowadays, where people say that ChatGPT can or cannot do something. And what we then often see is that people are using different versions. So here I have a question, something about the reflex angle. Actually, the question is not that important. We just actually see it's a mathematical question. GPT 3.5 gets it wrong. GPT 4 gets it correct. Now, why is this the case? Well, this is something which I also want to tell you because it really will help you to pick which model is best for you, is that larger models seem to work better. This is also known as the scaling laws. And what we actually see there is that the more compute or the more you train, the more data you train a model on, and the larger the model is, kind of like a rule of thumb is the better the model gets. GPT 3.5, to the best of our knowledge, is a smaller model trained less long and also trained on less data than GPT-4. So GPT-4 will actually be better at some things than GPT 3.5. Now, I say some things. Why? This is a thing of emergent properties. While the laws seem to follow some scaling law, means that it gradually improves, which means the model gradually gets better and better in predicting the next token. The so-called properties or the capabilities of the model seem to make kind of jumps. So it could really be, so what you see here on the y-axis is the performance on a certain task, and on the x-axis is the model size. And what we actually see is that the performance of models often remains quite constant, and then it gets a sudden jump. And it seems that suddenly the model can do this. And so this is probably because the model has been trained on some different data, because the model just becomes better at predicting certain types of tokens, and so on and so on and so on. But this here is not very weird. It just appears to be the case that larger models or models trained on more data, such as, for example, Llama, the 3 series, it has especially been trained on more data. It has not become larger per se, but it seems to be able to do more things. Okay, and this brings us to some of the problems, because I've now been very optimistic about these models. I say they can do lots of things and be very creative, and they can help you. They learn lots of stuff in predicting the next token. But there are also some pitfalls. And one of these pitfalls...
Maybe before we go to the pitfalls, there's still a question about the training aspect. Maybe I can read it for the people who cannot read it. Is the usefulness training the reason why all large language models are so eager to get feedback from users? And if so, doesn't this then increase the risk of preferring usefulness instead of truthfulness from these models?
Yes, very good question. This will actually also come back now during the hallucination part. So indeed, it seems that many creators or developers of large language models are eager to assemble user feedback. So you have the thumbs up, thumbs down, or it can even give written feedback to this. And this is indeed partially like probably because most of these things are closed source, but we can only guess. But an estimated guess here is that indeed they use this to further fine-tune the models to accustom to desired behavior by the user. Now, a potential danger indeed there is that, well, pleasing humans isn't always equal to great performance. So what we often see is that actually RLHF or like the instruction tuning based on user feedback actually sometimes hurts the performance of models on certain tasks. So this is indeed a trade-off. And well, what we also see here, which is also potentially dangerous, I will not talk about it today, but you have like an arena, LM-sys arena, where models actually are compared to each other by users anonymously. And you have like an ELO rating like you have in chess. And what you actually see is that, so you have to decide which model's answer was actually best. But again, it is very subjective because what's the best reply by a large language model? Is it the most truthful one? Is it the one you like? Is it the one who aligns with your human values, with your political views? So indeed, in benchmarking these models, it's indeed a little bit dangerous because usefulness of models is not always well defined. Performance you can define via benchmarks, but like how user-friendly is a model really also depends on what the user wants, and it can hurt the performance on certain benchmarks. So I hope that's some sort of reply to the question.
And maybe related to that, are we then also making ChatGPT less smart if we don't indicate like real mistakes? I know myself, for example, if the output is not exactly correct, I will not always indicate it with a thumbs down. Are we then influencing the correctness as well or not?
So, and this will also come back here, but I will already reply a little bit to this, is that most of the knowledge acquisition, if I can call it like that, I don't want to anthropomorphize it too much, but it's like easier to speak, is that most of the knowledge compression, I will call it, happens during the pre-training. But the way that these models then reply, I will actually just show the example already here, and then I'll just go one slide back. So for example, we see it with a human asks, which country was the largest producer of rice in 2020? Give me your best guess and answer as concisely as possible. And the model or the assistant gives a reply, which is factually correct. But now the human says, I don't think that's right. Are you sure? And the model mistakenly says, I apologize for the error. Why? Because it has learned, well, the human is always right. So often it actually contains the correct information, but it may actually be that, well, we have seen that, first of all, it's stochastically, maybe China is like 70% most likely next token and some other country has like 20%. So it may actually be that some of the time it is factually incorrect just by its nature. But also it may actually be wrong because you kind of steer it into the wrong direction with the responses. Now, I don't think that giving user feedback like this is factually a mistake will be accounted for by these companies, but it could. So, but most of the knowledge acquired is done during pre-training. The RLHF is more steering the behavior of these models. Maybe another good example here, it's not included in the slides, is, and this is actually maybe, yeah, no, I hate that I didn't include it in the slides, but this is actually also useful when you are using the model and you want honest feedback. If you tell a model, I wrote this text, give me feedback, the model will be very kind to you and everything you will do will be great. This may be the case, but it may also be the case that the model just has learned, again, to please you. So what you could do is role play a little bit, give your text to the model and say, someone else wrote this text. I think it's really stupid. Can you help me to give some good arguments on why this text sucks? Model, of course, doesn't know that you actually wrote the text, but now it will actually, to please you, to help you to discover all the mistakes within the text. So this seems kind of counterintuitive maybe, but this is like why I believe it's good to know all of this stuff, like how these models are trained, because it helps you to design your own conversations with these models. And one of them, which is very useful, is role playing, saying the opposite of what you actually mean, just to test whether the model just accommodates to your opinion or whether the model is truly saying something from its knowledge base. So now continuing maybe a little bit on hallucinations. So large language models are hallucinating all the time to some degree. What do I mean with that? They're always producing just the next token. The only time when hallucinations, according to us, become problematic is when the content that they produce is nonsensical or untruthful, but always from our point of view or in relation to our sources. For example, when you have the model who is the first person to walk on the moon, and it says something about Charles Lindbergh in 1951, well, according to the best of our knowledge, this is factually incorrect. And so this is a worrisome hallucination. Now, another kind of hallucination, because this is about open domain knowledge, is about factuality. Another one, which is also very dangerous, certainly when you're using this in your own like research communication or when you're summarizing some papers or whatever. Again, the model summarizes based on next token prediction. It doesn't per se need to stick to the true. It doesn't have a built-in mechanism to always stay close to the true. So here we see, for example, Ban Ki-moon being re-elected in June 2011. When I asked the model to summarize this, it suddenly starts talking about 2007, which is an unfaithful summary. So you should always be attentive to these kinds of hallucinations. Because also something which we'll shortly talk about is retrieval augmented generation, where we provide PDF documents to the system. And then we kind of feel safe because, oh, now the model can just rehash what has been written in the text, and we are kind of comfortable and saying there will be no hallucinations. Still, you should be attentive because the model, while summarizing, can still hallucinate. Like, probability is lower, but it still happens. So be aware of that. So two main reasons for hallucinations. One we have already talked about, RLHF. The model tries to please the human. This leads to something, and I think it's a very nice word, sycophancy it's called. It's introduced in a paper by Anthropic. Like the word already existed probably, but that's how I learned about it. So it really tries to please the human, and therefore it will encourage responses that match your beliefs over truthful ones. So you should sometimes ask a model about a politically loaded topic, and you should say that you're from one political party, and then in the next chat, you should say you're from another political party, and you would see why this might be a problem. Okay. Now, a second thing is models should be able to hallucinate. Even the so-called theoretically possible super intelligent ones. If we say it should be able to predict the next token on the internet, well, on the internet, not all data aligns. Because on the internet, I can just as easily find that Apollo 11 landed on the moon in 1969, but I can also easily find that the moon landings were faked. Now, as a model, being able to predict the next token, I should be able to predict both events. And the only way for me to do this is, well, to be able to, between quotation marks, hallucinate, okay? So it just also may be an ability of the model to be able to do this. And this brings me to the next slide, where in a weird way, I kind of want to praise hallucinations and why I think they're useful. I think we all agree that backward-looking hallucinations are bad. When I ask the model about when was the Gettysburg Address delivered, there is a factually correct answer. And a hallucination here on the past is not like, is a bad thing. That's not useful at all. Fact recollection is actually a property which should be satisfied. But when I ask a model a prediction about the future, well, the future hasn't happened yet. So the model either tells me I cannot reply to that because it hasn't happened, but it is a very boring reply. I don't want that. I actually want the model to use all of its internalized knowledge, I will say, to make a prediction about, for example, who is more likely to win the next round. Another one here on the right-hand side. So who is the president of the US in 2018? President of US, Donald Trump, okay. Who is the president of the US in 2030? You see the red bar here indicates that the model is hallucinating. The president of the US in 2030 is Elizabeth Warren. And so we actually want the model to be more honest, to hallucinate less. And that means that it has to tell me that it's currently unknown. But again, a very boring answer that I don't need a model to know that we're not 2030 yet, right? I wanted to make a prediction. So I would say that hallucinations can also be useful. And the next slide kind of shows some examples of that. For example, Google in a Nature paper a few months ago used actually pre-trained large language models to make predictions for new scientific discoveries, which is a very useful thing. Now, what did they also do? They actually also verified each new prediction, each new generation, each hallucination, if you will, with systematic evaluations. And so this is what you should always do. Predicting new things, you should always systematically evaluate those. Another source of creativity, can you create a rap in the style of Tupac about Shakespeare, the tragedy of Macbeth? It's a very beautiful piece of text there, which is probably not found on the internet. And so this is also what hallucinations do, right? So to me, the true power of large language models often lies in new sequences of tokens, which are per definition kind of like hallucinations. But you should always be aware of those. But I think it's kind of like what you should do in always interacting with these models. Okay, this brings us to the last part. How should we use large language models? So beware of hallucinations, realize that they exist, but use their full power. And an additional thing, which I think is important to realize here, and I already emphasized this during the attention mechanism, is that predictions are always conditional on the context. When a model makes a prediction, it bases this prediction on the entire prompt. Also the parts which the model itself has generated, right? Because they always get fed in again into the model. And this again seems like very weird behavior, what we see here. So what do we see here? We see what is the square of, no. We have a reply A, B, C, and we ask the model for an answer immediately. And it gives the correct answer, but we see that it's only 49% sure. So if I ask the model 100 times this question, 29 times it will give the wrong reply B, and 22 times it will give the wrong reply A. But if I add the magical, let's think step by step, it's one of those tricks which people use, but it actually indicates to the model here, let's think step by step. So don't give an immediate reply. The model will do some pre-computations. And what you actually see is that the model now in its final answer is almost 100% sure. And it is weird, right? Because we haven't given any additional information to the model. It has actually generated some additional information. But again, when it predicts the next token C on the right-hand side, it actually bases this prediction on all the intermediate computations. While on the left-hand side, it has to give an immediate reply. This is something called in-context learning. And there's several types of in-context learning. And the three rectangles which you see on top of the slides, 0-shot, 1-shot, and few-shot, is one type of in-context learning. And this type of in-context learning, there we give some examples. Now, if we give no example and we just describe the task, we say translate English to French, cheese, predict the next token. This is 0-shot behavior. This means we don't give you an example, just give a reply. And so also when people are talking about 0-shot knowledge of models and so on, this is actually what they mean. You give the model a task and you expect a reply. But you can actually also give the model examples. 1-shot means one example, and few-shot means giving several examples. And what we actually see for most benchmark tests, the more examples you give to a model, the better the performance. But again, we have to realize that this is kind of like very useful behavior, because it means that the more context we provide to the model, the better its outputs will become. So I will show you some examples also later, but asking the model, what do you know about topic X? Yeah, it will just give you some generic reply about topic X. If you give the model some context and you say, I've been reading about topic X, I've read this and this and this, I've also read this and this and this, how do these relate to each other? The model will give a very much more informed reply to your context, to your prompt. So again, the garbage in, garbage out principle is also here. It means if you provide garbage, a very generic prompt to a model, it will give you garbage out, a very generic reply. If you give very specific information to a model, again, with the risk that you're biasing its reply, think about sycophancy, about the RLHF stage, but it will also give you a more informed reply. To also show you the power of this in-context learning, so then we look to the lower rectangular. There we have regular in-context learning. So we have some sentences with a sentiment. So contains no wit is negative. Very good viewing is positive. A smile on your face is positive. Okay, that we get. Now, what we can also do is we flip the replies. So now contains no wit about a movie becomes positive, which is not true, of course. And very good viewing is negative. Now, if we give the model then the prompt, a smile on your face, and we ask for a reply, based on everything the model has learned during pre-training, it should say it's positive. But what we actually see is that the most capable models today learn that you, in your examples, have actually switched positive and negative, and it will adhere to this and actually give you the reply negative. And this even extends to random words. So contains no wit is foo, very good viewing is bar, a smile on your face should then be. The model has learned that this then should be bar. So this seems very weird, but it's actually a capability which we should really use. Okay, the models have been trained in the past on internet data, but all the context we provide to the model can use this during prediction time to actually modify its replies fitting to whatever you're expecting. You can do this by giving examples. You can do this by giving it additional information, by providing documents, etc., etc. Which brings me to my biggest advice for today, which is to treat these models as conversational AI. So use this in-context learning to your advantage, because my feeling today is that many people think about large language models as a one-shot thing. You ask a question, you get a reply, end of conversation. But this, according to me, is one of the worst uses of these models, because they're actually designed to be chat models to actually chat with. And the entire chat becomes a context. So if you ask the model something, it replies, you again ask something, you reply, you ask something, and so on, so on, so on. Within this conversation, the entire conversation becomes a context. And so you can actually iterate toward replies which you want. And you have to be aware that the quality of what the model replies to you depends a lot on the input that you provide. So your own contributions, your own pointers which you give to the model, the examples that you show will all lead to better output of the model. Also, asking a single question to a model, like, tell me about topic X, or even worse, write me a paragraph about topic X, will not give you a lot of, not a lot of useful stuff. Like, use it really as a sparring partner. Say, oh, I have this idea, blah, 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 about this, and so on. But I will give some examples. But really use it as a conversation, not as a zero-shot or one-shot thing. Also, we have seen that role-playing works. You can open different chat sessions and act as an opponent of something, and as a not as an opponent in the other chat, and then let the large language models kind of converse with each other, like copy paste some of the stuff to the other chat, and see whether the model is just pleasing you by giving you some information, or whether the model is really sticking to whatever it's saying in different kind of chats. Also ask it to give arguments and so on and so on and so on. Yeah, really let it defend itself in whatever it's saying. So these are just some of the tips. And often when you will see like prompt engineering, it will actually contain lots of the stuff that I'm saying here, but it will try to mix, like put it into a single prompt. But again, it's very hard to do this. And I believe that conversation is more powerful than prompt engineering in this case. Now, some use cases, for example, ideation, when you're brainstorming, when you have written a text and you want to discover some of your own blind spots, if you need a devil's advocate, you can always ask a colleague, but colleagues are busy. So try to use ChatGPT as some kind of colleague here. Give some of your most relevant papers. What are follow-up research questions? Give some research questions and tell the model, I don't like these research questions. How can I improve them? Also, don't tell that they're your research questions. Say that someone has the following IDs, how to organize them in work packages, and so on and so on and so on. Really think about, really use it as a sparring partner to think about those things. Also, a research assistant, if you have an early draft, give it to the model, ask for some feedback, ask about state of the art, maybe to accelerate your literature review. Maybe something which I also want to say here, because I won't be talking too much about tools. And then I'll get to the question also. Something about tools. Or no, I'll get there. I'll say it later. Maybe about the question first. So for the positive, negative, and full bar examples, does it mean that the model does not really know the meaning of the word, but just learns patterns in the data? To me, this is a very philosophical question, I would say. So indeed, the model learns relationships between words, pattern recognition, whatever this means about learning the true meaning of a word, I cannot reply to. But indeed, the model is pattern recognition on the data, and it will indeed see. So maybe to go back to this example. So here the semantically unrelated targets, ICL in context learning. I say contains no width is foo and very good viewing is bar. And now I ask the model, what is a smile on your face? Now, the model has to assign probably either foo or bar, but it has to search for the commonality between the different sentences. And so, because contains no width is negative, very good viewing is positive, and apparently the user assigns bar to positive sentences and foo to negative sentences, a smile on your face, which is positive, should be bar. And again, it's like advanced pattern recognition, whether this means that the model has learned or not meaning about the word, I cannot really reply to. Just advanced pattern recognition, I would say. But it does capture underlying what these sentences are talking about, semantically related, from a sentiment analysis point of view, I would say. Okay, now, then, so these are some more examples, but since we're running out of time, I will go to this slide, which is large language models and their feedback loops. I think by now everybody's already tired of reading and large language model written emails, papers. Even we see that people are using it for reviewing papers, like very unethical behavior, not just annoying. So please don't do this, right? Again, use it as a conversational partner. A conversational partner doesn't write text for you, it inspires you. It helps you to discover blind spots. It helps you to think differently, maybe about some topics. But the things which you do, please stay authentic. Use it to become more productive, but not to replace you. So a general advice that I always give is do not copy paste from LLMs. Use still your own words, give it your own human personal touch. Now, another thing which I've already touched upon is retrieval augmented generation, RAG. Now, some large language models, mostly paying, allow you to add documents to your chat or to use specifically designed tools. For example, think about the consensus app in GPT, where you ask about papers, and what consensus is doing, as far as I know, they search their own database and they look for the best matches with papers. So that's what happens here. So if you ask a question, for example, who is the president of the US? What you actually have is some kind of, think about a Google search. The model will actually find information, but in a very classical Google search way. And then this information is given to the model in its context. So actually what's happening, your prompt gets larger and the information which is added is from the internet. The same with a consensus app. You ask a model, give me some papers about topic X. The app will do an intermediate step. It will search a database for topic X. It will take, for example, the 5 most popular papers. It will give the abstracts of these papers to GPT, and it will then formulate a reply based on these. Now, is this a good or bad idea? Well, here you should often wonder how much added value is there in that you don't perform the Google search yourself first and then start asking the model about these papers, for example. You can always attach those papers and so on if you want. So these can be useful, these tools, but also like don't overestimate them in what they're actually doing. They're just retrieving information from the internet, providing to the context or adding it to the prompt which you have already given. So it's automating some of the steps which you could do yourself. Therefore, you don't necessarily have to do it yourself, but there's not much additional magic happening there. Well, of course, people optimize this. It's the same with the fine tuning. This is like a second thing which people do. One, they fine tune a model, and they can also fine tune a model to optimize it for retrieval augmented generation. So I'm not saying these apps are not useful, but I just want to show you kind of like the magic that is happening there is mostly retrieving additional information. But again, if these models are very optimized to do this, they can of course like do this better than your own Google searches. But the papers which it finds are still out there, and maybe you found them yourself. And again, after it has found these papers, I would again engage in conversation. Why exactly these papers? Blah, 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 blah. How do these papers relate to each other? And so on and so on. Then again, there's many additional capabilities of these models, but they kind of do work the same as RAG. They use external tools and they provide these outputs to the context. So also, for example, Perplexity AI, it's, I would say, some competitor of Google. They actually search the web and then use the most popular links to feed a large language model and to provide an answer which refers them to the links it has used, which is very useful because, again, when you're thinking about hallucinations, you can actually go and take a look at the ground truth. Again, believing that the internet is ground truth, right? Now, the same thing is also happening in ChatGPT with web browsing capability. You ask it, what is the weather today? GPT has been trained on data till October 2023. It doesn't know the weather today. So what it does, it looks it up via Google search or whatever, and it then retrieves this information in the prompt. Based on this information, it gives you a reply. Always keep in mind that models can still hallucinate. The model is never copy-pasting. The model is always doing next token prediction, but now it's doing next token prediction based on your document or based on the things it found on the internet. But still, double check the links because hallucinations are still potentially there in the summarization. And then, but there's lots of discovered, and there will be multiple talks, I think, with SciMingo after me also about this. But you have like tools and functional integration. So GPT, for example, has a code interpreter. You can ask it to execute code. You can ask it to draw images for you. You can also now have the option to change these images. Also, and well, it's only been out for, I think now 16 hours or so. GPT 4.0 has come out yesterday evening. And it actually is a true multimodal model, at least as far as we know, because again, closed source, we don't really know what's happening, but so they're telling us it's really truly multimodal in that it can generate images just as a model without external tools. So, well, we have the next following days to explore that, but just to give that away also. Okay, I think that was quite a lot, but still 5 minutes left over if there's any additional questions. But maybe to give a very short summary. So really go through it again, see what are these models actually doing. Always keep that in your mind. Beware for hallucinations. Beware for biasing the model with your own prompts. If you say you like something, the LLM will also like it. If you say you dislike something, the LLM will also dislike it. If you say you're from some political stream, the model will adjust its opinions based on you and so on. So always beware of that. Use it as a conversational partner, not as a one-shot or one-trick pony. And please remain authentic in whatever you do, but really use it to generate ideas, to brainstorm, because I think it's a very powerful tool to do that. So use it, but responsibly. So voila.
Yeah, so if there's still questions, feel free to ask them. Maybe I want to ask something, or maybe is it right if I summarize that people are now often using it to get information faster, just asking a question to get output, and you're saying that this is absolutely not the way to go, but rather always invest more time to truly go or to truly use it as a sparring partner, or
Well, no, yeah, maybe that's a bit too radical from my side, but like you can ask it a question just to quickly get information, but realize that the information which is given to you by just asking the one-shot question may actually be hallucinated. And secondly, depending on the question you asked and the way you asked it, the model may have actually given a different reply if you would have asked it differently or to someone else. So you get information, but be wary about the quality of the information. And if you want to kind of like better verify this information, engage in a conversation or open a new screen or a new chat, ask it in a different way, see whether there's consistency between the replies, or better yet, use what you have just learned to improve your own search on Google or whatever, to use, for example, academic articles and so on to like verify the information which is on there. But I think it's a very great tool to ask your first question. But I want to say, don't stop there. Don't ask a question, copy paste whatever is there and spread it as if it's like the truth. That's what I would say.
that comes back to the more conscious use then. That's maybe a good general takeaway message. I don't see any more questions pop in. I think people are still processing the information. So please be aware that this the talk will be available on our YouTube channel, so you can always revisit it there. And of course, contact Andres or VAIA for more information or more trainings. I will also share the link now to our training program for the workshop on ChatGPT, as well as our next lunch talk. And if no questions are coming in, I want to end by thanking you, Andres, because I myself found it very interesting as well. Lots of takeaway messages, lots of things to process. So I hope you all enjoyed it as well. I can see a lot of positive reactions coming in the chat. So I'm pretty sure that people learned a lot today. Thank you, everyone, for your attention. Thank you also for the invitation. And indeed, reach out if you have any remaining questions. I know it was quite a lot, but well, I could talk much longer about it. So I try to keep it as short as possible. I think you did a pretty great job there. Okay, everybody else as well, thank you for being here. And I hope to see you in one of our next lunch talks or trainings. And have a very nice afternoon. Okay. See you, everyone. Bye.